Good morning, students. I am Dr. Sunayana Ashok Gurgaonkar, Associate Professor. I am associated with SS Zondare College of Pharmacy, Asangao, and I would be taking your topic antihistamines. We are particularly concentrating on this topic because histamine is the mediator of hypersensitivity, and this histamine is released during allergic reactions, and we will try to inhibit the release of histamine by using antihistaminics, so we would be able to treat all the diseases that occur due to release of histamine, particularly allergies, uh, cough and cold that occurs due to allergy. We will now have a look at the chemistry of histamine, the synthesis and the metabolism of histamine, uh, the classification, and SAR, what is called as the structure activity relationship of histamine. Let's have a look at antihistaminics. Typically, what do you mean by histamine, antihistaminics, or histamine H1 antagonist? You must all realize when we say the term antihistamine, then it historically refers the antagonist only of the H1 receptor and not of the H2, H3, or the H4 receptor. It is typically the antagonist of only the H1 receptor. Now, you see, I had already said and discussed that histamine is an important chemical mediator of hypersensitivity reactions. These are the reactions that are responsible for allergic responses. Let's have a look at the structure of histamine. Typically, histamine is made up of imidazole ring and an ethyl amino group, which might be present either on the fourth or the fifth carbon. And you will see that according to the IUPAC rules, the numbering will start with a nitrogen that is not associated with any double bond. Now, why it is fourth or the fifth carbon, we will see in the upcoming slide. You will see that the double bonds in the imidazole ring, they are constantly moving, thus creating two tautomers of histamine, the N-tau tautomer and the N-pi tautomer, and therefore you will see that sometimes the ethyl amino side chain is appearing on the fourth carbon and sometimes it's appearing on the fifth carbon, and that is why you will see that the IUPAC nomenclature of histamine is 4 bracket 5, that is either 4 or 5 carbon is associated with 2 amino ethyl side chain. Therefore, the name of histamine is 4 bracket 5 2 amino ethyl imidazole. Particularly, this is an imidazole ring. Now, what are the properties of histamine? It's a basic compound, and at pH 7.4, it almost exclusively exists as a in a monocationic form. You will see that histamine is synthesized or stored in mast cells, particularly basophilic granulocytes also. So, histamine is mediated by specific cell surface receptors known as the H1, H2, H3, and in modern times also the H4 receptors. Let's have a look at the synthesis and metabolism of histamine. You will see that histamine is particularly synthesized from amino acid histidine. When histidine decarboxylase enzyme acts on histidine, then what is synthesized is histamine. You will see that the acid group is now removed and what you get is histamine. So histamine is basically synthesized from amino acid histidine. This histamine now should also get metabolized. Every compound in the body that is in the form of chemical eventually gets metabolized due to enzymes. You will see that his, histamine is metabolized uh, first by N-methyl transferase, which will transfer a methyl group in place of hydrogen that is associated with nitrogen of the imidazole ring. And you will see that SAM, what is also known as S-adenosylmethionine, is getting converted to S-adenosyl homocysteine. This is the normal way in which the methyl group from S-adenosyl methionine would be transferred to the histamine, uh, to the towards the nitrogen that is present in the histamine, and the hydrogen of the histamine ring would be knocked off. In a similar way, enzymes, monoamine oxidase, diamine oxidase, which are present in the brain and the periphery, and aldehyde dehydrogenase, would also act upon histamine and convert the side chain into an acetic acid. You will see that histamine is converted into imidazolyl acetic acid. So these two compounds, N-methyl histamine and imidazolyl acetic acid, both are further acted upon different enzymes such as DAO, and aldehyde dehydrogenase to form N-methyl imidazolyl acetic acid and imidazolyl acetic acid.